Every day, millions of barrels of oil and natural gas are transported through an immense network of pipelines that span continents, oceans, and some of the world's most extreme environments. From deserts to dense forests, from frozen tundras to the seabed, this infrastructure is vital to global energy supply. But it also comes with significant risk. Leaks, corrosion, flare stack degradation, and structural failure can result in environmental disasters, economic loss, and even fatalities. Traditional inspection methods, whether through ground patrols, helicopters, or offshore diving teams, have always been high cost, high risk, and time consuming. But in 2025, the industry has entered a new era. Welcome to the age of drones and pipeline safety, a game-changing development that's reshaping how oil and gas companies operate. Today, we'll explore how drones are revolutionizing the inspection and maintenance of pipelines and associated infrastructure. We'll look at real-world applications, like leak detection in the Permian Basin, flare stack inspections in the Middle East, and offshore drone deployments in the North Sea. We'll also examine the latest technology powering these drones, from AI integration to sensor upgrades, and how government regulation is accelerating adoption. Let's begin. Why the industry needed a change. Pipeline infrastructure stretches for over 2.5 million kilometers globally, with large portions located in remote or inaccessible areas. For decades, oil and gas companies relied on ground-based patrols, manned aircraft, or satellite imaging to monitor this network. While somewhat effective, these methods are labor-intensive, expensive, and often dangerous. Consider this. In the past, detecting a methane leak might require a technician to travel several hours to a remote site, manually inspect equipment, and take readings using handheld devices. Offshore inspections were even more complex, involving helicopter flights or underwater ROVs that took days to schedule and execute. Meanwhile, problems could worsen undetected. It's not just inefficiency, it's risk. And when millions of dollars in the environment are on the line, time is critical. Enter drones, faster, safer, and more precise. Drones eliminate much of the logistical nightmare. They can fly into hard-to-reach areas, gather real-time data, and relay critical information instantly. By equipping drones with advanced sensors and machine learning algorithms, oil and gas operators can now monitor, predict, and prevent issues more effectively than ever before. Leak detection using drones. One of the most powerful applications of drones in 2025 is leak detection. Methane, a potent greenhouse gas, often escapes from tiny cracks in aging pipeline systems. It's invisible to the naked eye and can spread quickly. Left undetected, even a small leak can cause environmental harm and escalate into a catastrophic rupture. In January 2025, Chevron expanded its autonomous drone fleet in the Permian Basin, deploying fixed-wing UAVs equipped with tunable diode laser absorption spectroscopy (TDLAS) sensors. These drones can detect methane concentrations down to parts per billion. Over the course of just 3 weeks, Chevron's drones covered more than 500 miles of pipeline and identified 14 potential leak sites. One particular location showed consistent methane spikes over several flights, prompting a ground crew to investigate. What they found was a hairline crack near a weld joint, slowly leaking gas. Thanks to the drone detection, Chevron was able to repair the site before any regulatory breach or environmental incident occurred. The cost savings? Significant. The environmental benefit? Even more so. In Canada, Shell is using quadcopters equipped with infrared sensors to monitor pipelines through snowy terrain, where human patrols are virtually impossible in winter. These drones also use machine learning to distinguish between background heat sources and potential gas leaks, improving detection accuracy over time. Drone-based leak detection isn't just efficient, it's quickly becoming mandatory, especially in jurisdictions tightening emissions regulations. Flare stack inspection. Flare stacks are essential for burning off excess gas during refining and processing. They operate at extreme temperatures and heights, often exceeding 100 meters, and require regular inspections to ensure structural integrity and operational safety. Historically, inspecting a flare stack meant shutting down operations, cooling the flare, erecting scaffolding, and sending a team to perform manual checks, a process that could take days or weeks. Today, drones eliminate the need for shutdown. At BP's onshore refinery in Abu Dhabi, flare stack inspections are now performed using thermal-resistant drones fitted with ultrasonic thickness gauges in thermal imaging cameras. In a notable June 2025 inspection, a drone flight over the facility's primary flare tip revealed a temperature anomaly. The heat patterns suggested uneven combustion, prompting further analysis. Engineers discovered that debris buildup was partially blocking the flare tip, something undetectable from the ground. A maintenance team addressed the issue during a scheduled downtime, preventing costly emergency repairs and reducing emissions. Drone use in flare inspections reduces risk to human inspectors and saves companies millions in lost production time. As of mid-2025, major companies including ExxonMobil, Total Energies, and Aramco have all integrated drone-based flare inspections across their assets in the Middle East and Southeast Asia. Offshore platforms and long-range drones. Offshore rigs are some of the most challenging assets to maintain. With harsh weather, saltwater corrosion, and logistical hurdles, regular inspections are both vital and expensive. Enter long-range waterproof drones. In March 2025, Equinor, Norway's largest energy producer, rolled out its latest initiative, using BVLOS beyond visual line-of-sight drones to monitor platforms in the North Sea. Launched from the coast, these drones fly up to 250 kilometers, navigate pre-programmed paths, and hover near flare stacks, risers, and support structures. They transmit real-time video feeds and high-resolution data back to engineers on shore. This innovation has already paid off. In May 2025, Equinor's drone footage revealed early signs of metal fatigue on a support beam connecting a flare tower to a bridge platform. Immediate reinforcements were scheduled, preventing what could have been a structural failure in one of Europe's busiest offshore zones. What's even more impressive, these drones operate in all weather conditions, thanks to corrosion-resistant casings, anti-icing tech, and AI-powered navigation that adjust for wind and wave conditions. Equinor estimates that drone use has cut offshore inspection costs by 70% while enhancing safety and reducing turnaround times. Artificial intelligence, the smart eye in the sky. Drones are no longer just flying cameras. With AI integration, they become intelligent inspectors. Modern drones are outfitted with onboard AI chips or connected to cloud-based analytics platforms that analyze data in real time. This allows for automatic detection of cracks and corrosion, predictive maintenance alerts, asset tracking and comparison over time. Shell Canada, for instance, has partnered with a startup called Skylogix AI, using drones that scan pipelines and feed data into a predictive maintenance platform. The software uses past inspection data, weather conditions, and vibration patterns to forecast which sections are most likely to fail next. In one case, a drone flagged a suspicious discoloration on a pipeline joint. AI identified it as corrosion weeks before any visual damage appeared. A preemptive repair was made, avoiding a shutdown and a potential spill. This blend of drones and AI transforms inspections from reactive to proactive, a true leap forward in industrial maintenance. Regulatory compliance and environmental monitoring. Governments around the world are tightening environmental and safety regulations in 2025. In the US, the EPA's methane reporting mandate now requires energy companies to conduct quarterly inspections of all pipeline infrastructure. Drones are quickly becoming the inspection tool of choice to meet these mandates. Why? Because drones can record GPS-tagged video evidence, provide methane concentration reports, log historical inspection data automatically. Total Energies uses drones to perform monthly environmental assessments in Nigeria's Niger Delta, where manual inspections are logistically challenging and security risks are high. Drones equipped with multispectral cameras also help detect oil spills on land and sea by analyzing surface reflectivity. In April 2025, a spill in Malaysia was contained early after drone footage revealed subtle surface changes off the coast, alerting cleanup crews faster than satellite imaging could. As environmental accountability becomes central to ESG reporting, drone deployment is no longer a luxury, it's a necessity. The future. The future of drones in oil and gas isn't just about better cameras or longer flight times. It's about automation, autonomy, and integration. Many operators are moving toward drone-in-a-box solutions, autonomous systems housed on site that can deploy, recharge, and return without human intervention. These smart hives are already being piloted in Alaska and the UAE. Real-time 5G connectivity, coupled with cloud-based monitoring dashboards, is enabling remote teams to manage assets from anywhere in the world. Imagine a drone in Oman being monitored by a technician in Houston in real time. That's already happening today. Furthermore, as AI models improve, drones will start making on-the-fly decisions, adjusting their flight paths mid-air to follow anomalies or inspect new concerns automatically. The ultimate goal? A completely automated pipeline safety network, flying 24/7, adapting to new risks, and protecting both infrastructure and the planet. From detecting invisible methane leaks to scanning high-temperature flare stacks, from patrolling freezing forests to inspecting remote offshore rigs, drones are rewriting the rules of pipeline safety. In 2025, they're no longer futuristic tools. They're frontline workers, safer, smarter, faster. The oil and gas industry is flying into the future, powered by innovation and guided by necessity. Thanks for watching, and if you're as fascinated by this transformation as we are, don't forget to like, subscribe, and leave your thoughts in the comments below.